For this question, we want to determine the real solutions to the system of the nonlinear equations. Our system is y squared equals x squared minus 9, and negative 2y equals x plus 3. So we can solve this system using substitution or elimination. And as I'm looking at this, I can see that I have a y squared and a y. Those are not like terms. An x squared and an x, and those are not like terms. So I'm going to try the substitution method, because the elimination method requires that you be able to add the equations together and eliminate one of the variables. If your variables are not like terms, you're not going to be able to add them together to eliminate. So I'm going to try this with the substitution method. So as I look at these different variables, I notice that this one, x, doesn't have a coefficient on it, and so that's going to make this the easiest one to solve for. So I'm going to start with that second equation, negative 2y equals x plus 3, and I'll solve for x by subtracting 3 on both sides. So I have negative 2y minus 3 equals x. And now that I've solved for that variable, I want to substitute into the other equation. I'm going to substitute in for x into the other equation. And that gives me y squared equals negative 2y minus 3 squared minus, that should be a 9. And this gives me an equation with only one variable. And I want to simplify. I've got y squared. Negative 2y minus 3 is negative 2y minus 3 times negative 2y minus 3. Minus 9, we'll multiply that out. We have positive 4y squared, positive 6y, positive 6y, and a positive 9, and carrying down that minus 9. I'll combine like terms to get 4y squared plus 12y. I'm going to move all the terms to the same side, so subtract subtract y squared. And I have 0 equals 3y squared plus 12y. I want to solve this equation. I can solve it by factoring. I'll factor the greatest common factor of 3y, and then I'll be left with y plus 4. I can set each factor equal to 0 using the zero product property. And that gives me y equals 0 and y equals negative 4. So I have two ordered pairs and the y coordinates of both of these ordered pairs. And I need to find the x coordinates. So what I'm going to do is I'm going to use this equation right here since it's solved for x. I'm using the equation x equals negative 2y minus 3. And if y is equal to 0, x will equal negative 2 times 0 minus 3, and that's negative 3. So one of those ordered pairs will be negative 3, 0. Then the other one has a y equals negative 4. That's x equals negative 2 times negative 4 minus 3. That's 8 minus 3, which is 5. And so I have the other ordered pair being 5, negative 4. So I have the real solutions to this system of equations being negative 3, 0 and 5, negative 4. Thank you for checking out my videos. Have a great day.